To the fourth webinar in the Northern Grapes webinar series. It's titled Grape Disease Management Basics and all about Anthracnose. Our speakers today are Patty McManus and Wayne Wilcox. Patty is a professor in the Department of Plant Pathology at the University of Wisconsin-Madison. Patty is also a member of the Vineyard Studies team on the Northern Grapes Project, and her research will focus on disease susceptibility of the Northern Grape cultivars. Wayne is a professor in the Department of Plant Pathology and Plant Microbiology at Cornell University. Despite not being a member of the Northern Grapes Project, Wayne has graciously agreed to present at today's webinar and share a small bit of his vast knowledge about grape diseases with us. So thank you, Wayne. Remember that as a participant in the webinar today, you will not have the ability to speak. If you are having any technical difficulties, please type a note in the chat pod over there on the left side of the screen, and I'll do what I can to help. If you have any questions for our presenters regarding Anthracnose or any other grape diseases, also type that question in that chat pod over on the left side of the screen. And Patty and Wayne may answer some questions as the webinar progresses, but most of the questions will be answered during the break between Patty and Wayne's presentations and also at the very end of the webinar. So with that, I'm going to switch the screen layout over. And as soon as Patty's presentation loads, I'm going to turn it over to her. So Patty, there you go.
Okay, well, thanks a lot, Chrislyn. Good morning or afternoon, depending on where you are. As Chrislyn said, I'm a plant pathologist with the University of Wisconsin in Madison and a cooperator on the Northern Grapes Project. Today, I'm really happy that Wayne is joining us. Wayne has many years of experience in grape management. I'm relatively new to grapes myself, so I'm going to be listening probably as closely as anyone to whatever it is that Wayne has to tell us. My presentation, though, is going to be on anthracnose. It's going to be fairly quick, about 10 or 12 minutes, simply because anthracnose is something that has shown up in kind of an unexpected way on some of the northern grape varieties. So anthracnose is sometimes called bird's eye rot, and this disease originated in Europe and is part of the North American European Disease and Insect Exchange in the 1800s. We ended up with anthracnose. However, we gave enough nasty things to Europe that I don't think we can complain too much about it. Historically, anthracnose has been considered a disease of subtropical grape growing regions, particularly those with really hot and wet conditions. And so in the U.S., that would be the southern tier of states. And worldwide, one of the places where anthracnose happens pretty badly is in India, where they grow grapes for raisins. Now, in cooler climates, such as the northern U.S., anthracnose disease pressure is generally less intense, and historically this disease has not been a big problem, possibly because it's been controlled as a side effect of some of the other diseases such as downy mildew, powdery mildew, and black rot. However, as I mentioned already, the disease has shown up in sort of an unexpected way in some of the varieties that we favor in the northern climates. So anthracnose is caused by the fungus Elsinoe ampollina, and the asexual form of this fungus goes by Sphaeciloma ampellinum. And that will be the last time in this 10 minutes that I'm going to say those words. But if you're out Googling, you might run across either one of those names, and just be aware that they are, if you see both of those names, they are referring to the same thing. Anthracnose, as I mentioned before, is sometimes called bird's eye rot, because sometimes the lesions on fruit can resemble a bird's eye. In this unfortunate cluster of Valiant, actually there are so many lesions on the fruit that the bird's eyes have kind of melded together. Let me see if I can pull the arrow over onto the fruit cluster. And there's other things going on here too. We've got downy mildew and probably black rot there. On leaves, as we see on the right, lesions are roughly circular and they're brown to black in color. And in advanced stages, the middle of the lesion will actually fall out. And so this is actually an air hole here, giving it a shot hole appearance. In some of the older literature, you'll actually see the name shot hole used to describe this disease. Lesions can develop on petioles and rachises, and so certainly on rachises you can lose entire clusters when that happens. On the right here is a you know, a young shoot that's been affected with severe anthracnose, and superficially it can almost look like frost injury or chemical burn. In the lower left is a cane affected by anthracnose, and this is important actually for a couple of reasons. The most obvious is that if you get too many of those lesions, it's going to weaken canes, but it's also the case that the anthracnose fungus likes to overwinter on cane lesions. And so that leads us into the disease cycle for the anthracnose pathogen. The fungus overwinters as hard fungal bodies that are called sclerotia in the cane lesions and to a lesser extent in infected fruit. And then in the spring, when you have periods of extended wetness, at least 24 hours, and temperatures above 35 degrees, spores will start coming out of those sclerotia, and the spores are spread by rain. Now the spores are going to be spread in rain droplets and by wind-blown rain, so definitely the spores will spread about within a vine, perhaps to neighboring vines, but not a half mile or a mile away from another vineyard. It's just not that kind of disease that spreads over long distances. So the spores are not all that particular about the conditions under which they germinate. So all they, with about 12 hours of continuous wetness, temperatures of 35 degrees are good enough, all the way up to 90 degrees. And in fact, as you get up into the 80s, it only takes about 4 or 5 hours of continual wetness to get infection. And all soft succulent parts of the grapevine are susceptible to anthracnose. So after infection has happened, it takes about 4 to 13 days before you start seeing symptoms, although I should mention that the symptoms shown here are probably much farther advanced than 13 days. It actually takes a bit longer to get them this noticeable. But just to summarize, disease development is optimal at conditions of about 75 to 79 degrees, but of course it can develop over a really, really wide range of conditions. So what can you do about anthracnose? Well, I think maybe the first very important thing to do is to make sure that you know what it is you're looking at. So anthracnose can sometimes resemble phomopsis. Certainly once you get familiar with identifying these diseases, they're pretty distinctive. So, but I encourage you to become familiar with both these diseases. Anthracnose, sometimes hail injury, when the plant starts to recover from it on canes, that can almost look like anthracnose. But if you do have trouble with diagnoses, I believe it's the case that all of our land-grant universities still have a diagnostic clinic. Many of these are free, but probably these days I think most of them charge a fee, but it is a modest fee. So whether it's for grapes or something else you're doing, I do encourage you to use that facility in your state. Okay, well, if you've had anthracnose in the past, sanitation is going to be really important. So you want to be sure to remove as much diseased tissues as you can, and also to get rid of wild grapevines that might serve as a source of spores. Now, as I mentioned earlier, the anthracnose spores are probably not spread great distances, but nevertheless, having disease or insect-ridden wild grapevines near the vineyard isn't a good idea in any event. After sanitation, a way to further knock back fungal inoculum in the spring is to apply lime sulfur just prior to bud break. And this may be beneficial not just for anthracnose, but for phomopsis, possibly even powdery mildew as well. Although for both of those diseases, you certainly are going to need more control later in the season beyond that, that dormant spray. But in the case of anthracnose, if you're going to use lime sulfur, be sure to check the label. There are various products. Make sure that Grape is listed, and then be sure to use a rate that is on the label. And also be sure to spray in an adequate volume for really good coverage of canes. So the fungus is overwintering in those lesions on canes primarily, and so if you want to eradicate the fungus, you really do have to give the canes a good soaking. Now the good news about anthracnose is that if you have a good spray program for downy mildew and black rot, then you're probably going to control anthracnose as well. Like black rot, it's the younger tissues that are more susceptible to anthracnose. So to control this disease, you need to protect young tissues and right up through viration. You should intensify the spray program if there's been a lot of rain, particularly during periods of rapid shoot growth. And of course, you want to redouble your scouting efforts anywhere where there's actually been a history of anthracnose and where highly susceptible varieties are planted. And I'm going to say more about the susceptibility of different cultivars in just a moment. Okay, unlike some of the other diseases on grapes, such as black rot and powdery mildew, downy mildew, there really hasn't been a whole lot of controlled, replicated research done for chemical control of anthracnose, and particularly not here in North America. Nevertheless, I did run across a couple of reports done within the past 5 or 6 years. One by Waldstein et al. Was out of Missouri, and that was under high disease pressure. And then Schilder and colleagues in Michigan tested some products under low to moderate disease pressure. And I'm not going to read this slide, but the main point I want to make is that there are a lot of different fungicides that are effective on anthracnose, and they're from many different fungicide chemistry families. So you do have to do something, or you'll probably end up with anthracnose. I think we've seen that already in the Midwest and some of the northern states. But chances are you're going to be using one or more of these products already for other diseases, and so anthracnose control really should be achievable. Now I highlighted pristine there because the pristine label actually lists anthracnose. And so if you were going out to control anthracnose and only anthracnose, then technically, to be legal, you would want to use a product that has anthracnose on the label. But honestly, I can't imagine a scenario where you're going to be controlling only this disease. I think in most cases you're going to be going after the whole gamut of diseases, and as I've said a few times already, anthracnose will get taken care of as a side effect. A couple of other products that are that actually do have anthracnose on the label are Inspire Super, Revis Top, and Quadris Top. Now all of these contain difenoconazole, and this is a newer sterile inhibitor fungicide. One warning about that though is difenoconazole, on the label it gives some warnings about toxicity to certain varieties. So be sure to carefully read labels before you use any of these products. Okay, well I mentioned a moment ago that you might want to intensify your scouting efforts and possibly your spray program where highly susceptible varieties are planted. So then that begs the question, what are those varieties? And there was a study published last year by some researchers with Agriculture Canada out of Quebec. And what they did was a greenhouse study, and I will say right up front that a greenhouse study is very different from what happens in the field. But to my knowledge, this is the only replicated controlled study on sensitivity of particularly of the northern varieties to anthracnose. So what they did, they had rooted cuttings, and then they showered them with anthracnose spores, kept the inoculated cuttings in a warm, humid environment, and then counted lesions after about 14 days. And they then after the 2-week incubation, or they then had 3 groups. The 21 varieties fell out into 3 groups, which they dubbed resistant to slightly susceptible if there were fewer than 10 lesions per leaf, susceptible if there were 11 to 30 lesions, and highly susceptible if there were more than 30 lesions per leaf. Now my own preference is that if I saw 10 lesions per leaf, even in this kind of trial, I think I would be reluctant to say resistant, so I'm going to take that word out of there just to make myself more comfortable. What we see here is of these 21 varieties that they tested, most of them fell into the slightly susceptible category, but there are a few important varieties that were highly susceptible in their trials, notably Marquette, Traminette, Vandal Cliché, and Swenson White. And some of these I know, at least in Wisconsin where I am, a few of these are definitely out there. So here's that data in a little bit more readable format. I just want to make re-emphasize the point that this greenhouse trial is not the same as in the field. They were looking only at leaves. They were not in the field. We're concerned about fruit. We're concerned about canes and raceses. But what I hope is that these data, and then coupled with our own observations, anecdotal observations, and some research that's going to come out of the Northern Grape Project, I hope that we can get a better handle on susceptibility of some of the northern varieties, both to anthracnose, but also to some of the other important diseases. So with that, I think we are in a position to take questions. Is that right, Chrislyn?
Right. And it looks like John Bruno has asked a question about vinifera susceptibility.
Okay, so vinifera is definitely susceptible. That's primarily what they have in Europe. At one time, this was actually the most important disease in Europe, and so it's certainly susceptible. I don't know, Wayne, if you care to comment any further on that. Feel free on any of these, Wayne.
Sort of the poster child for anthracnose on vinifera is Thompson seedless, which isn't really an issue for us in the east, but that's where they have trouble in the rainy springs in Australia. I think Chardonnay to some extent, but the fact that it is a European disease suggests that probably a lot of the European species of vinifera has some additional degree of inherent resistance that we don't find as much in North American varieties, which is probably why we're starting to see a lot of the problems showing up more than we'd anticipated on some of these northern varieties that have a pretty high degree of American blood. So just sort of the opposite situation that we have with the mildews and black rot, which are North American pathogens, and the North American varieties have more resistance than the European V. vinifera varieties do.
Okay, thanks, Wayne. It looks like a couple people are asking if you can get a little closer to your microphone or turn up the volume or something. In the meantime, Kevin Youngerman asked a question about suggestions for small-scale vineyard infection studies, portions of vines, individual vines. I would be thrilled if some people would do this, and so I guess one comment I'll make. I noticed that in this study that was conducted in a greenhouse, rather than trying to grow this fungus in culture and make spores, they actually took diseased leaves and crushed them up and used that for their inoculum source. So I don't know if that answers the question or not.
Okay, guys, let's go ahead. I guess while Wayne's presentation is loading, Patty, if you want to answer Patrick's question about grape pathogens having genetic variability, and is that true for anthracnose? It's going to take Wayne's presentation a bit to load.
Yeah, it's a great question. I would be surprised if there isn't genetic variability, because how could there not be? There's genetic variability in anything that has genes, but boy, I'm not aware of that being documented, and like I said, not a whole lot of research done on this in North America. Maybe what I need to do is dig deeper into Indian literature and some published in languages that I don't understand. But sorry I can't answer that better, Patrick.
Okay, so let's go ahead and turn things over to Wayne now so he can get through his presentation. He's got a lot of really good information for us. So Wayne, I will let you go ahead and take control.
I'll do a real quick sound check. I did turn up the volume on the microphone. Does this sound better? Still very faint, they say. Well,
You guys can also turn up your volume on your speakers on your computer because we don't want to get it too loud for Wayne because then we might get a lot of background noise from his office. So if you guys could turn up your speakers, that would work.
okay, I will adjust it, but I've got it turned up about 3/4 to 7/8 of the way up. All right, that's as loud as I can turn it up on my unit here. Okay, well, I'm going to go ahead and start.
Okay. Yeah, we'll just go with it, and people can turn their speaker volume up a little bit if they need to.
All right, so I'm going to concentrate on the 5 diseases above the dotted line there. Of course, I think we all know that there's a whole plethora of fungal diseases that we have to control on different types of grapes in humid climates. And I listed them sort of in approximate order of what I'm thinking will be issues or would have started to become issues on some of these northern varieties, and I could be wrong, and you can correct me if you would, please. But anyway, the downy, black rot, powdery, Anthracnose, and Phomopsis, and then below the line, botrytis on perhaps a few varieties, especially tight clustered varieties, and then wood cankers, which will probably end up becoming a problem over time. These are very slow developing diseases that we start running into problems, after vines have been in the ground for 10 or 15 years, and we're not there yet, but hopefully we will be. So with that, we'll go along the order of downy mildew. That's sort of the idealized picture of the symptoms, those yellow spots that you can get on very young leaves, typically in the late springtime, sometimes referred to as oil spots. And here you flip them over, and what you see on the right there is that fuzzy downy growth. That's the sporulation of the fungus, and on the left is this is a fall infected leaf or late summer infected leaf that is not showing those classic oil spots, but is obviously very infected. Well, if you take a leaf like that out to your barn and put it under the electron microscope, what you'll see are these these little tree-like structures of all the spores, and that's what flies around and causes the disease to spread. Clusters can be very susceptible. The young clusters, downy mildew is like many of our pathogens. It's an organism that likes to infect. Prefers young, very succulent tissue, and so here we see some clusters that have been infected actually before flowering occurred, and then a red-fruited variety there that's where the berries have been infected, well after they formed, probably towards the end of their period of susceptibility, 2 or 3 weeks after the fruit had been set. Sometimes what you'll see on later infections, symptom sometimes referred to as leatherberry, where these the berries get infected after the physiology is capable of supporting sporulation, so you don't see the growth of the fungus, but obviously it's in there and just destroying the berries, and that can make it a little difficult to diagnose, and sometimes that is confused with a Phomopsis fruit rot. Probably the more common symptom, although this is an unsprayed vine, and we don't have too many of those that last very many years. But the more typical symptom that we deal with downy mildew are the foliar infections and the resultant defoliation that can occur. And obviously, if it gets to this point, you're not going to be able to ripen the fruit or ripen the wood for that matter. So we do run into problems, especially later in the year as the disease starts building up. People get sick and tired of spraying in a wet year, and this keeps going, and we get some premature defoliation and the bad things that can happen as a result of that. The conditions for development, this is definitely a disease of humid climates. It needs all the stars have to be in alignment for it to happen, and when they are, it can happen real fast. And what those stars are is you need warm, humid nights, above 95% relative humidity, so for all intents and purposes, rainy or dewy nights. This causes the organism to produce spores. When we have cloudy days following that, it allows those spores to survive. If you've got bright sunshine, they will die, and then the spores will germinate. They need water to germinate and cause infection, and what that is heavy dew will do it, but warm rain is really the by far the more common source of the free moisture. And as with anthracnose, a fairly wide range of temperatures, about 50 to 85 Fahrenheit, but temperatures in the 70s would be ideal for this, and for our younger Canadians, we're talking about temperatures in the mid-20s Celsius. As I said, we can have very rapid buildup of this of disease, so it's very explosive. You go from almost nothing to a whole bunch in a matter of a couple of weeks. If we have persistent favorable conditions, it's because we have about a 4 or 5 day generation period, how long it takes from the time of an infection until you get these lesions and a new crop of spores that can spread the disease. So you get this exponential explosion when you have the right conditions. Conversely, if we have extended dry periods, as we often do during the summer, this disease sort of goes on vacation, and there's nothing happening until we get back into these conditions. So as we know with any of our intelligent pest management operations for disease and insect and weed control, you're not always spraying just because something could happen. You're doing it because you think it's likely to, based on what you understand of the way that this thing works. You don't just necessarily go out there every week during the summer, whether you need to or not. So when might we need to spray? The first infections, at least in our region here, can occur about 2 to 3 weeks before the start of bloom. That's when the soil gets warm enough. It has to get up to around 50 Fahrenheit or 10 Celsius. We have to have the leaves with functional breathing pores on their underside, the stomates. That's where the infection occurs. So looking over 30 years of weather records and disease occurrence records in Geneva, we find that it's always right around 2 to 3 weeks pre-bloom. Generally around Memorial Day, if it rains, we're going to start seeing powdery mildew. Downy mildew. This is the time to start on highly susceptible varieties. For our northern varieties, La Crescent is one of our most susceptible. You know, if it's wet, again, if it's bone dry, you wait until the other starts turning on us. Anything that has susceptibility to this disease will definitely need to start by bloom. The organism is active. There's plenty of susceptible tissue, and of course, as you saw from those earlier pictures of the clusters that are infected, the economic loss from infections that can occur in this pre-bloom and bloom period are a lot greater than a couple of spots on the leaves. This will take out clusters. The spread can occur on the leaves throughout the season if the conditions are right. The clusters only remain susceptible for, depending on the variety and the test and everything, somewhere around 2 to 3, maybe 4 weeks after the start of bloom. But for all intents and purposes, it's pre-bloom once the clusters are there, and for the first couple of weeks after. That's when you have to worry about the clusters. But young leaves can stay susceptible throughout the season, and the disease can build up and spread when conditions are correct. And as I say, it can become epidemic if it gets started and isn't controlled. And oftentimes, when we get into the mid or late summer, we've gotten some established. We're getting into warm, muggy, dewy nights, and people sometimes are a little tired of spraying, etc., and it'll take off. Most of the states have their, and provinces have their own publications on materials that can be used, but just sort of a quick review. The old standards for downy mildew control are Catan, Mancozeb, and copper. Copper was the first downy mildew fungicide, and it still works. And it is far and away the most effective control measure acceptable control measure for people who want to try to produce grapes organically. Quite effective, used all over the world. It is confined, all of these are effective and widely used, confined to the tissue surfaces, which means they can wash off if the rain is heavy. They only give protection against new infection with no post-infection activity. Another material that's used very widely for downy mildew control is the phosphorus acid products, also sometimes called phosphites or phosphonates. These are not fertilizers. They're sometimes sold as fertilizers to get around labeling requirements. But the standard P fertilizer is phosphoric acid or phosphate. So the phosphorus acids, there are several that are labeled for downy mildew control. There are a number of quote nutrient solution and plant tonic formulations that have the same active ingredient, but they haven't registered them for downy mildew control, and that's sort of a gray market. Basically, the law says is it's legal to apply them, and it's legal to get downy mildew control with them. It's only illegal if you do it intentionally. These are not organic, strictly speaking, so they're not Omni approved, but they certainly fit what a lot of people's philosophy is for organics, or integrated or sustainable. They're effective, relatively economical, and extremely low toxicity. In fact, the U.S. EPA exempts them from residue tolerances. So there's no limit. There's no pre-harvest interval. There's no maximum amount. The EPA, for toxicity purposes, considers them benign. Some other materials that are used, the strobilurins, pristine and abound. There have been significant resistance problems to our south, where downy mildew is controlled pretty intensively. Ridamil products, this is really the big gun, very expensive, but when you need the nuclear option, that's what it is. And there are several newer downy mildew specific materials that we don't have time to go into now, but information on that is available pretty widely. Switch over to black rot, a disease that has been showing up in some of the newer northern plantings, I think primarily where people just haven't been aware of it. It can be a devastating disease, but it's also a disease that's really very easy to control with conventional fungicides, difficult to control, or can be difficult under high pressure for an organic approach. And as one of my later slides says, this, in some places anyway, is really the Achilles heel or potential Achilles heel for organic production, because when it does get going, it can result in significant crop loss. What I've shown here with the that 1, 2, 3, 4 with the arrows is a progression of the symptoms, where we see that that number 1, the green berry that's halfway rotted. We go up to 2, where the disease has progressed and taken out the whole berry, and is starting to form some spores, a bunch of little black dots, spore bodies. Get a little bit past that, and we get to number 3 as the berry starts shriveling up and raisening, and then we get down to 4, where that process is complete, and it's a hard, dry mummy, and these really stick pretty tightly. The infection occurs before the berry has started to form a separation layer between itself and the berry stem, and so once it dies, it's pretty well stuck on there, and you can give it a bit of a tug and it will stay on, and that's one of the things that will distinguish it from some other fruit rotting organisms or fruit rot diseases that that end up with mummified berries. Black rot, another symptom, doesn't really do a lot of damage, but it certainly shows you that this is the disease that's present. Are these leaf lesions? You can see the size there. They have a very distinct, dark margin around the edge, and in the center of those, if I had a slide with a close-up, you'd see a bunch of little black fruiting bodies about the size of a pinhead. So the disease cycle, we'll just not spend a lot of time on that, but just remember that the mummies are the source of the disease. They're the source of the spores in the spring. It overwinters primarily in these mummies, and then kicks out spores that cause new infections of the young fruit, and then as they start getting into that number 2, 3, and 4 stage of forming new spores, and then it can spread within the cluster, and that's when it really takes off. So you can get just a couple of early infections, and then you have all these spores being produced right around the healthy berries and washing onto those and taking out the cluster, unless you're doing something to intervene. And basically, that means spraying something that works. As with virtually all of our fungal diseases, we have a relationship here between we have to have the tissue has to be wet to allow the spores to germinate, and it has to be wet for a certain period of time for them to germinate and cause an infection. And that's how long that is depends on temperature, and you can see the relationship there, showing that it's really black rot is a disease that likes it on the warmer side. The ideal is in the 70s to mid 80s Fahrenheit, but it will cause disease under cooler conditions if it stays wet long enough. The berry susceptibility, the work that's been done on this has been done with vinifera's and Concord. On Concord will be obviously the closest thing that we have to the northern varieties. The berries remain highly susceptible from as soon as the cap falls off and they're exposed until about 2 to 4 weeks later, and some retain susceptibility until about 4 or 5 weeks post-bloom, and after that the berries are quite resistant to infection. You can inoculate them with spores, or we have tried to inoculate them with spores and not gotten disease. So we get to this. I don't know if I can use my yeah, arrow doesn't work on my computer. There it goes. A busy slide here. What I want to show, this is the results of several years of spray timing trials, where that 3 with the asterisk, where you have the green arrow, that timing is right at the start of bloom, and then number 2 is 2 weeks before that start of bloom spray, and that's a further 2 weeks, and now we're going 2 weeks after the start of bloom and 4 weeks after the start of bloom. And what we're showing here is percent control. What we'd like to get is 100, and you can see at this 3, 4, 5 one that we managed that 5 years out of 5 where we ran this test on the hybrid cultivar Aurora, which is very susceptible, and by targeting that period of berry susceptibility, we're able to control the disease. So it's a really not too difficult with a limited number of sprays if you have the timing right. Here, if we left off the early spray, we lost control there, and here if we stopped too early, we lost some control there. The fungicides Mancozeb and Zyram are old standards. They give good control under most commercial conditions. They are strictly protectant fungicides. They're active only on the surface of the fruit and the leaves. They have to be present before infection begins. They are subject to wash off, but they work. The DMI groups, such as Raleigh or Nova, the tebuconazole generics, these various difenoconazole products, metal, these are all really excellent. They have some protective and significant post-infection activity. And for people that have a real black rot problem, these are the best that we have. Although the others that we just talked about, the protectants, are quite good. The strobies, pristine and abound, very effective. Sovereign and Flint also. All the strobies are quite effective. Now, Captan is not very effective against black rot, and neither are copper and sulfur, and those are underlined because those are the backbone of a lot of organic producers' programs. Those who aren't growing varieties that are sensitive to those materials. But in big bold letters there, black rot's the potential Achilles heel for organic producers. If you're trying to grow these things organically, you really have to emphasize, you can't overemphasize the importance of sanitation programs. So there's it's a picture that I took in an organic Niagara vineyard a few years ago, and the fungus decided to leave a couple of berries, but certainly not enough to worry about harvesting. They don't have to look like that. The point is that they can, and so it's an issue. So the control strategy, sanitation. What do I mean? I mean, get the mummies out of there when you're pruning. I'll show you the importance of just simply getting them out of the canopy and dropping them onto the ground. If you're an organic producer that has to do great sanitation, then ideally get them out of the vineyard. If that's not practical, when you're pruning them out, throw them out into the center of the of the aisles and disc them under, or cover them with mulch so that the spores can't get from the mummies up into the canopy. And emphasize the most important time for fungicides is from right at the start of bloom until about 4 weeks post bloom. This covers the period of very susceptibility, and by the time we get 4 weeks post bloom, all of the overwintering inoculum is gone. And so if you don't have any infections within the cluster, there's the fungus isn't there. Go back to this value of sanitation, the removal of the mummies from the trellis, and one of the reasons why. What we're showing here is the spores that are produced during the season from mummies, either that have just been dropped onto the ground or left in the trellis. And you can see that, if I can drag my arrow, well, I can't. Okay, the blue line there are mummies that are on the ground, and we get out to 6/19, so June 19th. After that, we weren't able to get any more spores off of those mummies, and that's just before bloom started. That's the blue arrow with the BL. Well, so we're those mummies down on the ground are they produced all their spores before we had any fruit present. Whereas the ones in the trellis, you can see in the red line, were producing spores all during that period of fruit susceptibility. So, well, why would the fungus produce spores when there's not, when there's no fruit there? Well, the fungus evolved before people came along and started pruning these mummies out of the canopy. I told you how they stick very tightly to the clusters. Well, that's what they do in nature, and they stick up there in the canopy. So it evolved to be making its spores while there were new young susceptible to eat, and we can circumvent that by pruning them out and throwing them down on the ground. So, as I said, the difference is if they're producing spores until veraison rather than, in some cases, there's another spore type that is produced from, for another week or two after bloom starts, but very, very few. 10 or 20 times as many spores over the season. And then lastly, they're producing these spores right next to the new fruit. So these things get moved around in splashing rain. And you can imagine if they're right there, how they can, it's much easier for them to get into the fruit that are the young berries that are next to a rotting berry than something that's down on the ground. And illustrating this, we have again, not being able to do the arrow, so I'll quit on that. But what we have is a young vineyard that we had just established. I was doing it on its own. That we had just established, and we wanted to introduce black rot into this vineyard to do some work on it. And my technician went and got some mummified clusters and just took little pieces and wired them in there. And what you can see is that all those shoot lesions that are occurring, which black rot will do under very, very high pressure conditions, all of those came from just those few mummified berries that were wired into the canopy. So I often say, if I go into a hot spot in the vineyard and there's a lot of black rot right there, the first thing I do is start looking for mummies that are left over from last year that are hanging in the canopy, and I almost always find them. All right, we'll move on to powdery mildew. Probably the most ubiquitous fungal disease of grapes all over the world, because it's the one that doesn't need water, free water and rain to give us infections. So, Mediterranean climates that don't rain in the summer, they deal with powdery mildew. So do we, but we deal with everything else, and they don't. Unfortunately, our northern varieties that are being grown have a lot of American grape blood, if you will, genes in them. Uh, and this is a North American pathogen. So we have some degree of resistance that vinifera and a lot of the vinifera hybrids do not have. But there's still some susceptibility, and we can't just ignore this disease. On susceptible cultivars, it can get on the berries, and when it does that, it will destroy them. That's Chardonnay, which is highly susceptible, and that's what it'll do if you don't control it on Chardonnay. So I mentioned native to eastern North America, so the viniferas are all highly susceptible, are natives with some resistance, and this wide range of susceptibility among the interspecific hybrids, depending on what the parents were and what the selection criteria were when these varieties were developed, if they were throwing out things high disease susceptibility or not. Disease cycle, the fungus makes its overwintering structures as those little black dots on the leaves. The infections that occur during the summer, these wash off and they lodge on the bark where they're protected and survive the winter. They germinate in the spring, and then they form the infections. That's the stage of the fungus that's going to repeat throughout the rest of the season. We can see right in the middle on the underside of the leaf a little there we go, thank you, a little white, which is the sporulation of that fungus. And then after this, so say we don't need rain. The development of the disease is governed primarily by temperature, where again we get up into the 70s Fahrenheit and 20 Celsius is where this fungus is the happiest, and we can get a new crop of spores, a new generation, and a buildup, every 5 or 6 days under those ideal conditions. So it can take off on us very quickly, whereas early in the spring it's slow to get started. Just real quickly to illustrate a point that spore lands on the leaf. It germinates, it makes this little infection peg, and then it sends that little sinker down into the top epidermal cell. That's how it feeds. But then as it feeds, it starts growing, but it grows on the surface of the infected tissue, and will then continue to send more of those little sinkers down to feed. But it's unique. Most of our other organisms burrow down inside the leaf or the fruit. Powdery mildews are almost entirely on the surface, except for those little feeding structures. Well, where that's important, okay, now it's making some new spores, but where it's important there is that the body of the fungus is out there and it's exposed to the elements in a way that our other organisms or other disease causing organisms are not. And that has some real implications about its management. There's the, again, firing up your electron micrograph, and what you'll see, microscopes, you'll see that picture of the spore there in the middle with the body of the fungus developing out through it and spreading out across the surface of the grape leaf. Well, one of the things that it's exposed to is sunlight, and we've looked at this quite a lot over the last few years. And one illustrative example here, you see this group of vines where it's the 1 and 2 that are next to this little group of pine trees, and they're shaded until noon every day, until the sun comes up over the top of those trees. Whereas the ones in the yellow, the 3 and 4, are out beyond those trees, and they're not getting that morning shade. And what my student Craig Austin did was inoculated leaves on the outside and then the inside part of the canopy on both of those groups, so that we'd have, you know, 4 different levels of natural shade. And just what you see is the ones that were away from the trees out in the cleared area, that were exposed on the out part of the canopy to the sun. There's 7 or 8% of the leaf area was diseased with powdery mildew, whereas all the way to the right there, the ones next to the trees getting, you know, shade throughout the morning, and then in the inside part of the canopy, there's about 7 or 8 times as much disease, and that's just strictly the effect of the sun. So pruning and training practices and site selection that does offer, you know, the best levels of sun exposure without sunburning your fruit is what we strive for. Okay, so the period of host susceptibility, another really important concept for powdery mildew management. Just showing on some Chardonnays, clusters that have been inoculated right at the start of bloom and 2 weeks later, with a lot of disease at the end of the season, whereas those that were inoculated 4 weeks after the start of bloom or later, there's virtually nothing on there. So that means that for controlling fruit infection, we have a very narrow window of susceptibility, which, if you'll recall, is all the same narrow window of susceptibility that we have for fruit infection by downy mildew and by black rot. So this is the make or break time for controlling several of our very important fruit diseases. Products that can control powdery mildew. Sulfur, which is organically acceptable, DMIs, strobies, a bunch of things. There are, these are alternative materials which are also organically acceptable because they work against powdery where they don't work against other things, because the fungus is on the surface. So things like oils and potassium salts like potassium bicarbonate, hydrogen peroxide, you know, oxidate, etc. So I'm getting the hook, being told to hurry things up. All right. Lastly, the last one we had was Phomopsis. We'll just emphasize that Patty showed you a Phomopsis picture earlier. The classic internode, basal internode infections, but where we really tend to lose, you know, economically from this disease is when we get infections of the rachis, and you can see that those berries are likely to either not form or fall off. Okay, there we go. Fruit infection. Some varieties are pretty susceptible to fruit infection, and the fungus can grow from the rachis into the fruit and rot the berries, as we see here. Infected wood within the vine, especially dead wood, is where the fungus comes from. It only really moves a matter of a few feet in splashing raindrops, and so that green shoot that you see with all the basal internode infections, the spores that cause that almost certainly came from that circled pruning stub, and you can just imagine how if that green shoot got pruned off and left a stub, well, there's infection there, and it would continue to produce spores over the years and infect newer tissues. Wide range of susceptibilities. We're going to have to just blast through that. Cultural practice, removing inoculum by pruning out dead wood, extremely important, and something that is you know, should be doing for other purposes as well. The time to spray is the period of very early shoot growth. May need to continue through bloom, but for most of our damaging infections occur early, and in a lot of tests that we've done that I won't show the data, a single spray somewhere around 3 or 5 inches of shoot growth will give us a lot of control, and I would consider that the minimum program for controlling Phomopsis. It's also a very good time to be controlling the anthracnose shooting infections, and these materials, mancozeb, cap-10, and zyram, that are go-to materials for Phomopsis, are also very good against anthracnose. Unfortunately, our organic choices for Phomopsis control are poor, so we have to rely once again on sanitation. So wrap it up with a generalized spray program. Dormant sprays, I'm not a huge proponent of them. They have their benefit, but they're expensive, unpleasant to use, but sometimes they are necessary. Lime sulfur for anthracnose, where you have an established anthracnose problem. I am told by people that have had to deal with a lot that this can be a mainstay for anthracnose once it really gets going. It will also provide some help against powdery and black rot in problem organic vineyards, but it's not, most people I think are not going to need or want to use that. The early period of shoot growth, when you've got a couple of inches long, Phomopsis, critical time. For anthracnose susceptible varieties, also an important time. We get up to 2 to 3 weeks pre-bloom. Phomopsis and anthracnose, if it's unsusceptible, cultivars and wet, still something that should be considered. Now we're getting into the start of powdery and downy susceptibility, and if it's wet conditions, this is when we start thinking about it. The immediate pre-bloom, and then sort of the late bloom and fruit set. This is the no-brainer time. Basically, if you're growing grapes, if you're going to spray, you are going to spray then, and consider 2 sprays are the critical ones that we just don't mess around with. You use your best materials. You don't cut corners. You get your best coverage. You just do everything right. Cut corners somewhere else, not then. Midsummer will be as needed depending on the cultivar and weather. Primarily, most of the time we're trying to control powdery and downy on the foliage. We may need to continue black rot control up until 6 weeks post bloom, if it's well established in the clusters. And for those relative few of you for whom botrytis control is necessary, there may need to be something done. Bunch closure and veraison, as you probably know. Then we get into this veraison and pre-harvest. Really not too often. The main thing that we probably would be thinking about would be if we have downy starting to get out of hand and we're trying to avoid premature defoliation. But I think most of our northern growers are not going to need to be thinking about spraying once we get past veraison. So I believe that is my my last slide, and I've used up most of my time, but we might have to answer a couple of questions. I do see right at the bottom here, Kevin mentioning the word about the need to rotate fungicides due to resistance issues. Yes, very, very good point. Let's see. Yeah.
Okay, Wayne, I'm going to give you some time to read through the questions and figure out answers, and I'm going to do a couple of announcements. So the first thing is just a quick word about our next webinar. It's Tuesday, May 8th, and Chris Gerling, who is an extension associate here at Cornell, is going to be talking about how to stabilize sweet wines. So registration for that isn't open yet. It'll open up towards the end of this month, and if you're on my email list, you'll get an email from me when the registration opens. One more thing, really important, the extension or the marketing and economics team has just put out their first survey. So the links for that are below. There's one for growers and there's one for wineries. If you're a member of one of our partnering associations, you should be getting an email from someone in the marketing and economics team shortly. We really do appreciate your participation in this survey. It'll create a snapshot of where the industry is right now, and then we'll also do this again at the end of the project so we can kind of see how the industry has changed over time. It'll take about 20 minutes. It might be a good idea for you to have some of your records handy, and you can start the survey and then come back to it at a later time if you're on the same computer. If you have any questions about the survey, you can shoot them to me. I think most of you have my email address, and we can go from there. So with that, I am going to turn things back over to Wayne and let him answer questions.
About replant disease. Well, that's one that I try to stay away from. It's a can of worms, and it's replant diseases occur of our perennial fruit crops. Poorly understood, but essentially they're complex of microorganisms that can build up over time, detrimental to if you replant the same thing back. It does occur. You can go into a site that didn't have grapes before, then you don't have to worry about it. There are plenty of people that replant vineyards in old vineyard sites, and they grow just fine, but it does have. We talked about ours on that one. The black rot, a couple of people asked. So we talked about, we've got this period of fruit susceptibility, and that's real easy. If we have synchronous bloom, we can say, okay, bloom occurred on from June 15th to 18th, and so I can tell you when 2 weeks after bloom is, or 4 weeks after bloom is. If we have a bloom period in one cluster that goes over for 3 weeks, then you're going to have some berries that are old enough that they're resistant to infection, but others that are still young enough, acceptable, and yeah, that's an issue. I think the question was, do we have to keep going till veraison? For black rot, you really don't have to keep going till veraison. That's the old textbooks say that, but the work that's been done not only by us but by others shows that they're resistant well before veraison. Let's see, rotating how close to harvest can fungicides be applied? Look at the label. It's different. It's different for all of them. There also can be some concerns. Some of the broader spectrum materials and things like copper, if you have high enough residues, or sulfur, about effects on vinification. So there's no one blanket answer, but the simplest one is look at the label, and they will tell you at least what the legal restrictions are. I think Kevin says black rot almost exclusively in unsprayed vineyards. Well, as I said, it's a disease that's very easy to control with conventional fungicides. It's a disease that if you don't control it, it can kick your hiney from here to kingdom come.
Okay, well, I think that we've gotten through all the questions. So I'd like to thank Patty and Wayne again for all the great information that you shared today. We really appreciate it. And also just want to make another shout out for our post-webinar survey. The link is in the top right corner of your screen. Your comments are very much appreciated. It just helps us improve our webinars in the future. So I think we're set. So thanks again, Patty and Wayne, and thanks everyone who joined in today. We appreciate your participation as well.
Bye-bye.
Thank you, Chrislyn.
Bye.